Hey guys, welcome back to my channel and this Okuma LS Adventures. I'm sharing the process of working on this nice Japanese lathe to show you guys what I'm doing, the thoughts that go behind it, and the steps of machining, hopefully to inspire a little bit to do the same, or at least to learn some metalwork or machining skills. I think we're all on a different level here. Maybe some are more beginners, others are way more experienced than I am. And yeah, it's just a process of learning, and I think it's valuable to share that. So with that, let's get started. This next step on this machine is mounting the DRO on the cross slide and the display. I will also make a solid tool post. I doubted a little bit what would be the first step. But then I thought, okay, hey, I can use the DRO to make the solid tool post. That would be very handy. But I can't use the solid tool post to mount the DRO. So yeah, easy choice. And let's get started and mount the DRO on this machine. So I will mount the linear scale on the headstock side. I did some testing with the Abbe Error, and for me I decided that it was useful to mount it on the headstock side. There is enough clearance underneath the chuck, and with the proper guard I'm not worried about damaging it. So let's give a little bit more explanation about the Abbe error. It's an angular error that will happen if you are mounting the sensor, something that you are measuring, further away from the point that you want to measure. Then there will be a difference if there's any movement in the system. If you mount it directly above each other and there's movement in the system, it will move in the same plane, so there's hardly any difference between the two. But if you move it further away and there's twist in the system, then there will be a difference between the point that you want to measure and the point that you are measuring. So that is the angular error, the Abbe error, and you can imagine that that is important if you want to do some more accurate work on a machine like this. With the DRO, if you mount it directly underneath the tool, then it will move in the same line, and there will always be some movement in the cross slide, maybe a twist on the gips or a slight bend on the waist. But with that, if you mount it on the tailstock side, there will be a slight difference. And there was a lot of discussion online if it would be worth it to mount it on the headstock, or how much this error would be. It's a little bit difficult to measure. You can also imagine that, this is such a heavy and big machine, but actually that doesn't really matter, because the bigger it is, the further away the measurement point would be if you mount it on the tailstock side and the tool side. So the further the distance, the larger the error. So maybe the error is even less on a smaller machine. And to get a better feeling or a better understanding, I spent 3 days of measuring this error on this lathe. Different radial forces, different axial forces, and that was very interesting, and I want to share that, but it's just too much video for this video, so I will make a separate video for that. In this video I just want to show you guys the basic results and show you guys why I want to mount it on the headstock side, and the more details about this Abbe error will be in a different video. So let's have a look at the setup. I got 3 positions to measure the movement in distance. One here is on the tool post itself. The other one is down there, and that is at the same plane as the tool itself. That one is hooked up to this indicator over here. And the other one is on the tailstock side over here. That is also almost in line and underneath the chuck. The other one that you see that I want to measure a little bit is the force. I took apart a weight scale and put the sensors in between the tool and some brass rod that I mounted in the chuck. So now it starts to get interesting, because I will pull on this rod, rotate force on the cross slide, the compound slide is fixed, and let's see how that influences the indicators. So I will just pull on here. Of course the wheel return a little bit. So let's have a look on the influence of the Abbe Error on this cross slide. I will pull on the leverage again to twist the cross slide, and let's see what happens. The one on the tailstock side is going negative, the one on the headstock side is positive, right with the tool itself. There's now some twist in the system. I can get that out again by moving the cross slide. So I back it up, move it back in, and you will see they're almost, yeah, they're all three nice back to zero again. And again, put some twist on there, and you see this one goes negative, this one goes positive. So I did the measurement 10 times to average it out and get some reliable results. I took away the one with the biggest error, because that could be a measurement error, and then averaged the other 9 and see about the headstock error on this line and the tailstock error on this line. So you can see the headstock averaged out on 0.09 of a millimeter error, and the tailstock side is 0.65 of a millimeter. So there you can already see some difference. And what would be interesting to see, if the error here on the headstock side is 9 thousandths or maybe almost 100ths, that is almost the same as the movement that I was still able to get on the compound with the fixed Gibbs. So in this setup, maybe the compound is causing the error and not the cross slide. So it would be interesting to measure it again with the fixed tool post. But for now, these are the results, and it's already clear that there's quite some difference between the two measurements and the error. I got two scales. This DRO came from a milling machine, so I got 3 scales, and I have 2 scales that I can use for this cross slide. These are mounted with M4 threads, so I need to drill some holes into this machine part, and yeah, I really hate doing that. And I must admit, this is the very first time that I will drill a hole in a machine. So first hole is done, and the other ones are here. I doubted a little bit, but I decided I will drill both so I can use both linear skills and I don't need to make the whole setup again if I need to switch between them, and at least that gives me one spare. These holes are 4 holes for protection cover for the linear skills, and I know I need some mounting. I don't know what shape of protection cover I will make, but I know I don't want to drill it on the top here. So yeah, I need to mount it, and I think 4 screws will be sufficient for that. So yeah, let's continue and drill some more holes. Finding the center mark is easy when you watch the movement of the drill. If you see it move just a little bit to the right, then you know you have to slide the whole system a little bit to the right. So I got one screw mounted, and there's about 0.8 millimeters of play. So one way to check, if I now pull in the other screw, so now the other one is also in, and you can see it has the same play. So that's one way to check if the center of the 2 bolts are in line, otherwise the play would change. So yeah, happy with that. Still some movement, of course up and down also, so enough movement to adjust everything. So I just drilled these holes for a cover of my linear scale for the lathe, and I want to check the centerline distance, and sometimes that's a little bit hard that you have to eyeball it on the center, but there's a little trick and some of you know it, but if you don't, then it's really easy and useful. Just zero it on the OD and then measure it on the outside of the pins, and it should read 0. So this is the prototype of a solid tool post that I will make, and a 4-way Barrett turret head, and about the average tick out of the tool that I would use, and I want to mount the DRO sensor right underneath that, so it gives as little possible Abbe errors. So I want to measure the position of these holes. So first what I did was mount it and then measure this distance from here. Then I got some reference, that's 22.4. Then measure it, and right here it lies flat. This one can twist a little bit, but if you measure both and they both measure the same, then you know this one is straight. It can also move a little bit up and down, but if you relax it, then it should be in a kind of 0 position. That one was 34.7, half the size of this hole. That was 2.65, and then when you calculate that, it should be 59.75 millimeters from the top here. So if you're brave enough, you can put a fly cutter in the spindle, but I guess I'm not that brave. So yeah, just a little bit of hand scraping, but it keeps me warm. So it's getting pretty close, and to check for any high spots I'm using this diamond coated flat stone that I know is pretty flat, and right now just rub a few times, and then it's pretty easy to see the high spots, but I don't know if you guys can see that. I'm not sure how it's on camera, but you can see here this spot is still a little bit high. But of course you can also check it with an indicator. Zero here, a little bit high, and back to zero. If you measure it like this, make sure you measure it from the inside here of the slide. Otherwise, this I started using this edge, but that was not straight. So yeah, make sure the measurement is correct, and just a little bit higher in the center. So let's continue scraping. I think in Germany they call this decent. So it's also nice and square. I need to hand drill these holes, and to get some nice straight holes in there, I 3D printed this drilling guide. So I put M8 bolt in there, drilled a 4.1 millimeter hole, and used that as a guide for drilling. And after drilling, then I need to tap it, tap thread M5 into the saddle. So then I will just loosen up the nut here, or the bolt, open up this hole for 5 millimeter, and then use this also as a tapping guide. So that's far enough for the tapping with the guide, and I do the rest without a guide. These are just a little bit higher than the markings that I put on there, but I knew that before the 3D print was not perfect, but there is enough adjustment in the linear scale mounting that won't be any problem. So these sensors are from Sony Magnescale. It's quite an old system, and they use a magnetic rod inside. And let's try to show you guys that. Come on. Yeah, there you can see it. So it will measure the magnetic field, and that rod is mounted on both ends. But this system should be quite robust, but it is only moving the sensor down the rod, so there's quite some movement, and even in the center it's up and down movement possible, because the whole rod will shift a little bit, and I want to measure that. So one solution is just bring it all in the back here where it is mounted. Maybe can also show you guys that. It's a little bit hard to get on camera, but I think you can see it. So here it is mounted, and here there is almost no movement in the rod. So what I do is I will take the turn the flashlight off, bring the sensor all the way to the end, right there, and here there's still some movement but a lot less, and from this position I can just measure it by setting some gauge block under it. So I got it here in the end, and I got a 9.5 millimeter gauge block, and if I press it you can see that the scale is lifting a little bit, and I switch these two with 9, then it's nice and flat and no movement. So 9 millimeter from the bottom mounting point to the sensor. The cover is just a cover, but it's not square with the mounting. As you can see, I'm pressing down hard. It's good solid on the base, but not on the outside of the scale. So that's one thing to keep in mind if you mount these. Just measure it from the mounting here on the back and not from the cover itself. So after all the scraping on this surface, it got a little bit behind this edge, so there's a little edge here in between, not as much here, but it is in here, so we need to measure that. I need to measure it upside down, but still this is exactly 1. Try again. And also 1. So 1 millimeter plus 9 millimeter makes 10. That's easy. You know what they say, guys, measure twice, cut once. Measured it again, came out different results, and I almost made a mistake because the cross slide was loosely on there and it was not pushed against the slide, and the grips were not in. So yeah, the measurement was all wrong. Measured it again, it's a little bit more than 0.5, and with the gauge block you can see it's a little hair more than that, but not much. So 0.5 it is, plus 9 millimeters will give 9.5. So I found some cold rolled steel that I will use. The steel is not that important, but at least I want to use steel and not aluminium. Put a wire in between because I'm not sure how straight it was, and then rotate it 90 degrees and keep it nice and square. So even without the DRO, the Shaolin is still quite a nice machine to use. So it's now nice and square on all four sides, and next step is making the thickness to 9.5, and it is now 8.5, 8.3, 8.4, 8.4. So I set the scale to 0 and then just adjust it 3.4 or 0.34 millimeters. I'll leave a little bit of room for maybe lapping. To be sure that it has nice solid mounting on the contact points, I want to open up the center part a little bit. So that's the next step. Still a little bit oversized, but there's a little difference between both sides, so I can get that out with some lapping, and then I know it has a good contact on both sides. So DRO works fine, mounting was quite good, happy with that. Next step is mounting the display itself, and I think I will do that on top of the headstock over here. I think that would be a good position, so somewhere around here. So I have a nice adjustable bracket that came with the DRO that I can use and mount on the cabinet here in the back, and then I can still swivel around a little bit and adjust it in height. The pivoting points were originally made of steel, but they were quite ugly and rusted, so we'll make a few new ones from stainless steel. That's better. These set screws have a very sharp point. I don't really like that on the stainless steel, and it's not holding much, so I grind a little bit radius on there. Alright guys, that was it for now. I'm happy the way it turned out. It's I think it's a good position to mount the DRO for me. The good thing is that I'm mostly left-handed, so I don't have to reach over the chuck, but I can reach from the left side. It's eye level for me, and I can tilt it a little bit if I need to, and put it out of the way if I don't want to use it. And it's slightly above the protection cover over here, so I have a clear vision on the scale. So mounting of the scale went alright. Was that the best you could do? Yeah. Next step is the Z-axis, and I will do that in a separate video. And after that I will make nice covers to protect the linear scales and organize the cables a little bit better. But for now that was it, and I hope to see you guys next time. Bye bye.